My CNC DIY router machine is officially tackling the aluminum material. The outcome is by so far not perfect. I cannot complain about the finished surface, but the time required for obtaining these results is not efficient in order to make products from this machine. My initial plan was to try to machine as many parts as possible of the new large design. But after machining this part, I will definitely take a step back and machine a less ambitious project, especially considering that most of the parts cannot be machined on the current machine that I have. I will have to pay a ton of money, a machine shop, for doing these parts. I prepared this new design that is just an update instead of a full machine design. Always trying to improve the current machine, I will replace the main 3D printed part of the Z-axis with one made out of aluminum plates. The design has been taking in consideration current machine troubles, a single setup for critical surfaces, datum features, and fixture and clamps. The current machine troubles are for X 240 and Y 160. So that means that I can easily machine parts of 200 millimeters by 100. And well, the thickness is not a problem, you know. I'm using my Z-axis design that is having a lot of trouble, something around 95. The thickness of the plates that I'm going to use are just 12 millimeters. A single setup for the critical surfaces is going to minimize the necessity of machine the entire faces of the part. The fixture should not apply bending forces on the features in order to let them be stable after machining. With this, what I'm meaning is that all the faces that should be even and that defines a feature for the linear guide rails or the carriages is going to be machined on a single operation. So everything is going to have the same origin at the moment. And all this is having a direct relation with the datum surfaces for alignment and straightness of the linear guide rails. Talking about fixtures, these two holes that are on the larger parts are because they are going to be my method for clamping. So the first fixture is going to hold the part while I create the two central holes and make the part finish on the total length of 200 millimeters. I will have a second fixture that is going to have two protrusions, same dimensions as the two holes, so they are going to be a negative, let's say. And I'm going to clamp down using the protrusion as the features that provide location, and two plates at the top that are going to push down the parts. Those are going to be located at the center, so they leave an open space for machining the other features. My method for the fixtures is not usual, but it consists of machined fixtures made out of high density plastic. I have the theory that these fixtures have the capacity of absorbing or damping some of the vibration. I should make more testings on this aspect, but as you can see, I have been using these type of fixtures for the current part that I have successfully machined. I have no doubt that this is going to be a good improvement. If the current machine with a huge 3D printed part that is cracked all over the place is capable to make this, the new aluminum piece is going to work perfect. If you want to know more about the errors that this current design has, I leave you this next video.